today is going to be a little bit different than the previous ones, only because we kind of have our basic game already set up from last week. So today I'm just going to start a brand new project, and I just want to show you guys some of the other blocks that are available in Scratch, and then I want to point you to a tool that we're going to use so that you can actually put your Scratch projects on a phone or an iPad or a mobile device.
Nice.
Okay, so it's really, really important, especially I don't know if you guys saw on the Spark website, but the student signups are going to start next week. And so basically what's going to happen for those is we're going to post some different exercises on the Spark website under the student training section. And they're going to kind of be like projects with goals that the students will have to complete. And you guys will kind of walk them through them. I'll also have all these tutorials that we've done on the website too, so the kids can watch those as well. And there's also other resources that I'll be posting, like the Scratch documentation and help files and things like that. But basically, every week they're going to get just a different goal that they're going to need to accomplish using Scratch. And then, hopefully by the end of the time when we get just before the Spark event in April, they'll be able to do everything you guys have done so far and then some. So today is really just going to be me going over the leftover blocks that we haven't covered in the past. I'll also stay after for a little while if you guys have any questions or issues or anything like that. Or like Nicole, if you want to go over your project from last week, if you had any other questions on that, we can absolutely do that.
No problem.
So, can you guys see my screen okay? Well, it's blank right now. There we go. Can you guys see my screen?
Yes.
And Melody, you guys can see my screen? I'm assuming you can see. Okay, I saw you nod, so that's good. Okay, so we've already gone over the motion blocks, and most of them should be self-explanatory. We talked about the X position, Y position. That's basically on our sprite, wherever the current position is of that character or that sprite. We talked about the event blocks. We went over messages last week in the teacher training. So if you guys have any questions on those, I can take those at the end. We've gone over most of, or at least the most frequently used looks blocks to change the size of our characters, to show them, to hide them, things like that. We've gone over the most commonly used control blocks. And I think the only ones we haven't done are the repeat until. So a repeat until block just does kind of what it sounds like. I'll do my flag clicked, and then I'll drag a repeat until block. This block does exactly the same as our our forever block or our repeat block, but instead of repeating a certain number of times or just repeating continuously on and on forever, it only repeats until some condition is satisfied or some operator is true. So in the case of last week, we had a couple variables like the score and the number of lives. We could have set up our game over screen to repeat until the the game to repeat until the number of lives was 0, and then the game over script could have been set up here. So we've got our messages here. So I could have done repeat until lives equals 0, and then broadcast the game over message, for example. So this basically will just keep repeating this over and over, and it won't proceed to the next item until that condition is satisfied. Okay, it's not like these other blocks. You can tell that some of these blocks, like stop all and delete this clone, they don't have that little tab at the bottom like these do. These just mean that you can insert things after those. So a lot like this wait 1 second block and the wait until block, this one will repeat constantly until some condition is satisfied. Does that make sense? Okay. We went over sounds last week. The majority of them, again, should be pretty easy. These are the top ones here are the most commonly used ones. If you want to see some of like these drum ones or the instrument ones, you can go on the Scratch website, go to Explore up at the top here, and pretty much just search for a tag like music or instruments. I think there's actually one that is a most loved one. That's actually like a keyboard, this guy, music maker. This one's basically, you've got all the notes going from top to bottom on the left-hand side of the screen here, and you can put down notes and then play them. So you can kind of hear the different kinds of sounds that you can make in Scratch.
That is so cool.
So you've got all kinds of stuff. You can change the tempo. And again, because every Scratch project you can look inside, you can just click See Inside to see how they're using those music blocks. Okay. Our next set of blocks, we're going to go over some of these in detail today once we're done kind of running through some of these. But we've already used some of these for touching. So to find out if one of our characters or one of our sprites was touching another sprite, there's some variations on this one, which are whether or not a specific color is being touched. And you can change the color if you click on the little color dot. There's a color picker that you can use. You can kind of see the colors changing there. There's also if one color is touching another one. So if you wanted to just do a very simple game with blocks, you could determine if one block is touching another color block, like if it was a safe zone, or if you're doing like a football game, you could determine whether the block was in the end zone or on the field or whatever, just by changing the color. You can check if the distance to some item, like in this case the mouse pointer, or if we added another sprite. Let's do an apple. If the distance from one thing to another. So this is basically, you'll notice this is a round block. So this means that there's some kind of value to it, like a variable. It will actually tell you the distance between the current sprite that this is attached to and whatever sprite or item is in the drop-down. Answer is another variable block, except this is kind of in tandem with the ask blocks. So in this case, if you ask what's your name, it'll prompt the player for an answer and then save that answer into this variable block called answer. If you have multiple questions that you want to ask in a row, then you can ask the question, have it automatically goes into this answer block, and then you can set the value of a variable. Answer 1. You can set that answer to this answer and save that, and then do that for each question as it goes on. We've also got some operators, so like the greater than or equal to. This is if a key is pressed, in this case spacebar, or whether or not a specific letter is pressed, the up key, the down key, the right key, the left key. So you can actually check. Some of these are already set up in our events. Our events actually have when a certain key is pressed, do this. So these sensing blocks just kind of give you a little bit more control over that. You can make your own versions of those blocks if you want to. Whether the mouse is clicked down, we're actually going to use this one today when we get into the pen blocks. So mouse down just says true or false, is the mouse currently being pressed down? Again, these round ones, those are some kind of value. So in this case, the mouse's X coordinate on the stage and the mouse's Y coordinate on the stage. Loudness is just the volume. You can add videos to your Scratch projects, and you can check whether or not a video is moving or what the direction of the video is, and whether the video is on the stage over here or on a specific sprite. So that'll give you a value. And actually, if I hover over some of these, it should tell me what the actual values are. So this one, if I click on it, it tells me it's 0. I don't have a video going right now. We can also turn a video on. We can set video transparency. So if you want to overlay a video as like a background or on top of something and make it see-through, you can do that. We can create a timer. So the timer variable basically is how long your Scratch project has been running. You'll notice that as I click on this, each time the value is going up. That's basically just how long from the time that we started our project, or sorry, from the time that we hit the flag that our project started, and we can use this block here to reset it. We can grab all kinds of data about any of our sprites. So again, we have under the motion blocks, we have X position, Y position, but on our stage, there are some instances where we might need to grab an X and Y or some other type of information about a sprite. We can do that using the sensing. So here, I can grab the X position of Scratch the Cat, or the Y position of Scratch the Cat, or the direction he's facing, or which costume number he's using, or his size or volume, and so on and so forth. Okay, so these are basically mostly values and operators that give us true or false responses or a specific numbered numeric response. Does that make sense?
Mm-hmm.
Okay. We've also got the pen blocks. Pen blocks only work on a sprite. They don't work on the stage. The only thing you can do on the stage is clear pen marks. But literally what pen marks are is they allow a sprite to draw a line. So if I double click on pen down here on Scratch the Cat and then start dragging him around, actually I probably have to use the motion blocks to move him. Let's do, shall do when space is pressed, move Scratch 10 steps, and then I'll also do pen down. So when the space key is pressed, put the pen down and then move 10 steps. So if I go into my stage and press the space bar, see how he's drawing a line now behind him? So you can actually do something that I call Etch-a-Scratch or Etch-a-Cat. And this is basically a project that uses the pen tool. When the flag is clicked, I clear the stage, but then I can use these arrows to move Scratch around. And then I can press this button to turn that pen on or off. Oh, that doesn't seem to be working. Oh, I didn't start the project. That might help.
Nice.
So now I can move Scratch around and kind of draw pictures just like on an Etch-a-Sketch. Oh, we got a microphone from somebody. Melody, can you say something?
Hello?
Hi.
Hi.
We can hear you
Oh,
now.
yay! That's random.
Yeah, that's really weird. All right. So anyway, we were on the pen mark. So you can also move the pen back up. That's basically what I'm doing here with this green button. If drawing is 1, then set drawing. So basically just alternate the two. And then Scratch, if drawing is turned on, then the pen goes down. Otherwise it goes up. And that just turns that pen on and off. You can also set the pen color to a specific color. The values of these colors, you can see as I'm moving the mouse around, it's picking up whatever color is underneath my mouse. So I can change it that way, or I can use the color by changing a value. I don't actually know what the full range of Scratch, actually maybe we can get help on this. See what the values are. No, it only gives us by specific amount.
How does it change the color by a value? Is it
So
like the. Go ahead.
it uses right here. You can you see my screen on the right? It says
Yeah.
pen color 0 is red. So it basically goes Roy G. Biv,
Oh,
and
okay.
it's on the color wheel. It's hard to visualize without actually seeing it, but it basically just goes red, orange, yellow, just like the colors of the rainbow, all
Hmm.
the way from 0 to 200.
Okay.
200 is technically 0 and 200 are the same value of red, and then everything else in the middle is just kind of looping around. And then it uses shades too, so to get darker and lighter values of those colors, then you use the shade here, and you can use negative or positive numbers. So positive will be brighter, negative will be the darker shades. Does that make sense?
Hmm.
Okay, you can also change the pen size. So if I want to set a bigger pen, I can make it a little thicker. I don't think there's actually a maximum size to the pen. Whoops. It's only single digits.
Does it do the size by pixels or?
No, they're like preset sizes. I think there might
Oh,
actually be like a limit to the size that you can actually do. It might be like 4 or 5 is actually the maximum. Yeah, I think
okay.
4. It must be 4 because I don't think it gets any smaller than that. Yeah,
Okay.
it's so 5 is the maximum size that you can get, and you can't do negative numbers on the pen size. I think if you do put in a negative number, it just interprets it as the absolute value, so it just makes it positive anyway.
Okay.
We've talked about our operators uh, for addition, subtraction, multiplication. We used the random number one last week, and we've been doing some comparisons with the equals operator. We talked about the modulo operator when we were working on our kitty drop game. So most of these are going to be pretty easy to figure out. Rounding is obviously just rounding up or down to whatever the closest value is. You've got a bunch of math operations here. I don't think we're going to use these in any of the student projects, but if anybody is, willing or has questions, you can always right-click, click help, and it'll give you. Well, I guess it actually doesn't give you too much. You can look up on Google, though, what each of the operators are. Most of them, again, are self-explanatory: sine, cosine, tangent, log. If somebody wants to get really crazy with math on their project, they are more than welcome to. To me, that's almost Greek sometimes, so I don't really try to get into that too much. Our data blocks, we've used variables quite a bit, so I'm not going to touch on those again. But there is a second variable type, and that's a list, or what's called an enumerated list. It works exactly the same way as our regular variables, except that you can add multiple items to it. So you'll notice here on the left-hand side of the screen, I have the name of my variable, which I called variable, and then it says length 0 and empty. I can add different numbers of items. So as an example, on our kitty drop game where we had the fish dropping from the top of the screen, we had talked briefly about potentially having different fish types in our game. It might make sense rather than having fish 1 speed, fish 2 speed, fish 3 speed, and so on and so forth, that we might just have a list variable called fish speed and have the first one be the speed of fish 1, the second one be the speed of fish 2, the third one be the speed of fish 3. So if you can group variables together in a way, if it's basically the same variable but just with small differences, then you can use variable lists. And you have the ability to add items to that list, to delete specific numbers. So the first, or a specific number, 1, 2, or however many there are. You can delete just the most recent addition to the list last, or you can clear the whole list out. Okay. You can insert an item at a specific position. So I can do 1A and put it in. Again, I can either write in position 2, And then if I double click that, it's going to insert it in between 1 and 2. Okay, I can get, again, these are rounded, which means that they're values. So I can get the value of the first item in the list, the last item, a random item. So if I wanted to do like our random XY values, but I wanted to limit it to specific spots, I can make a list of X coordinates and then just pick one at random from that, rather than just a fully random number. I can get the length of the variable, or just, that basically just means the number of items in that list, which you'll see listed down here, length 3, because there's 3 items. I can check if the list contains a specific item. So if I did item 4 and click on that, it comes up as false because there is no item 4. But if I come in with item 2, I'll get a true. This one is case sensitive and it has to be exact. It does not work if you have, you know, different casing, or if you're missing a space, or you have a dash instead of a space. You have to use those. And then I can show or hide that variable list, just like my regular variables. These don't have any impact on the game itself unless you're trying to show the player some value that's in that list. Otherwise, it doesn't do anything. But this is, again, just basically where you want to group variables that are very, very similar together. Does that make sense? Okay. And then the last one, I think with this group, we talked about it a little bit. The more blocks section are basically where you can set up your own functions. And again, functions, or just blocks in this case, are groups of blocks that we want to have happen over and over and over again on different items. So again, if we go back to the example of having fish, and each fish is slightly different, but they all act the same way. They all move from the top of the screen down. Or let's say we even wanted to introduce multiple item types, not just fish, but fish fall and fortune cookies fall, and maybe there's like a crab, but if the crab hits you, you lose a life instead of gaining a point on the score. The basic motion of all those things is the same, but there are just small differences between them. So for the motion, we could say make a block called move down. We have options, so we can add a number if you wanted to be able to put the speed, for example, of whatever the item is. We can add a string if you wanted to put the name. We can add a true or false value to our function. And basically all that does, I'll show you in just a second, but if I have move down here, when I go to run my actual block somewhere else, I can specify that number. And then this function will use that number when we call it. Does that make sense? So I'm going to write a quick function for Scratch the Cat. Let me just clear the stage off here. I'm going to write a quick function that we can use for Scratch the Cat. And then we can see how that works. Hide our list. I'm actually going to delete it. Okay, so here we have essentially the same commands. When somebody presses the up key or the down key or right or left, it's changing a value on our stage. It's changing Scratch's position, either his Y position or his X position. So what we can do is, if we wanted to do something similar but customize it a little bit, where instead of just moving up or down, we can actually have the user put in a value. I can make a new block called move scratch. Okay. I can add text, so I can put move scratch. Let's do a variable. So I just made a block now that says move scratch X spaces to the up, down, left, right. I guess to the up doesn't make sense, but hopefully the point still stands. So now I can make new blocks that say if the direction equals up, for example, then I want to change Scratch's Y position by that amount. Okay. I can also say if the direction equals down, to change the position by that distance as well. Okay. I can also do, and actually I can even simplify that. I'm going to put if direction equals up or down, then change by distance, because we know that negative numbers go down, positive numbers go up. And then I can do the same thing and do left, right, and use our X value for that. Okay, so now I can say, when I click up, move scratch one space to the up, or one space to the down. Again, grammatically doesn't make sense, but it should make sense here. And now he's moving one step up and down each time, which actually goes kind of slowly. Okay. And in this case, I need -1, not +1. Yep, down goes that, down goes that. And now the nice thing about these functions is all of this is now dictated already inside that block. I've already said that you can use this function however you want, and just by assigning the values right here, you can decide what to do with those blocks. Does that make sense? So you can make a function accept any kind of value that any other block in Scratch accepts. You can accept numbers as items, so we could do a speed of a certain numerical amount. We could have a block that says create a certain number of fish, for example, on kitty drop. Or we could do a point where add certain number of points to a high score, and you just type in the value of the high score. And again, the nice thing about this is there's multiple different places where we could be using this block, and the only difference between them are the numbers. Certain fish might be worth more points than others, but again, the underlying function or the underlying thing that that sprite does is the same. So we would want to separate that out. Anytime you can combine pieces of your code to be shared amongst different items, you'll want to do that. It'll make your program a lot simpler and a lot easier to understand. Okay. The last section here is what are called extensions. We don't have any extensions that we're going to be using right now. We're actually going to introduce these next year into Spark, but Scratch has outside third-party blocks that can be added to Scratch to use things like the Lego WeDo controller and something called a Pico Board. We're actually probably going to use the Lego WeDo next year. But basically what those do is you can create blocks, and Lego has actually created blocks that allow you to move a Lego robot around. So there's a block in Scratch that you can add that would say move robot forward or move robot backwards, or there's different motors that you can program on the block and you can name them different things. The robot has like a light sensor, it has a temperature sensor, a moisture sensor, things like that. So using all those different things, we can get a robot that says, hey, if the robot is moving forward and it detects water, grab a paper towel and clean it up or something like that. Or, you know, if the robot is moving forward and the lights go out, turn off, but when the lights come back on, start moving again. It's also got a camera on the bottom. So things that we've done in the past is we've had kids draw maps, like a giant map. Each kid gets a sheet of paper and they kind of combine using crayons or markers to make a color. They draw a map with a color. So basically, it's basically just a line, a blue line or a red line or whatever, and then we tell the robot to follow that blue line. So if the robot moves forward and the camera still detects a blue color, keep going. If it's, you know, moving forward and it doesn't detect a color, turn to the left until it detects the color again, and then start moving forward again. And basically it just follows whatever line you draw, those kinds of things. So there's all kinds of extensions that you can add to Scratch that allow it to interface with various other kinds of stuff. There's other robots and other science kits and STEM kits that you can get that integrate with Scratch. But the Lego one is the most popular one. So that's the one that comes with Scratch by default. And then that Pico Board. The Pico Board is the same thing, except you can use it to control different types of microcontrollers and little chips and things like that. So you can make it do all kinds of things. So that's basically all of the blocks in Scratch. Do you guys have any questions about any of the specific blocks that we went over? Do you want me to cover anything again or go over one of them again?
Did you say, we were kind of ruffled at the beginning, the kids can start to sign up next week?
Yes, if you go to the Spark website, sparkappleague.com, there's a button right on the homepage at the top. It's disabled right now, so they won't be able to get to it until the 29th. But when they click on it, it'll ask them to sign up their names. So you have a maximum of 3 students per team. They'll sign up their names, their team name, and then kind of what they hope to get from Scratch. And that's basically what we're going to use, from Spark. That's what we're going to use for like our final attendance tally. So they have to sign up during that week. If they don't sign up, they won't be able to attend the event because we have to give ASU a list of all the students that will be attending.
Sure. Let me ask you another question. Okay, so we both have, I don't know, 100 students, let's say, and well, we're not obviously taking 100 students to this thing, but we want to kind of have all of our students learn this. What would be your suggestion in terms of those tasks? Is there a way to take those tasks that are not in the competition, I guess, for lack of a better word?
Yeah, the competition is actually, you guys can do all the tasks and the projects that we're going to post to the Spark website. Those will be public and open for everybody. They're not actually part of the competition. What the competition or the contest is the day they get there at 8 a.m. on April 28th. There's going to be like a brief introduction. We have some speakers from game design companies that are going to talk about coding and stuff like that. But then the actual contest is we're going to give them certain criteria and they'll need to make a game based on that criteria. So they won't be able to prepare beforehand. They won't be able to set up anything in advance. They're basically just going to kind of walk in, find out what type of game they're making or what the criteria for the game is. And then they'll have until the end of the following day to make a game. They'll essentially have 24 hours to make a game.
Okay.
Does that make sense?
Yeah. So but all of our kids can do the tutorials or what the tasks.
Yep. And if there's any kids that are interested in not necessarily attending the event, but they would like to participate in it, we are actually going to have a Google Hangout set up like this, which hopefully we'll test out in advance with the teachers so that we know it's going to, work immediately the day of. But students are actually going to be able to attend, I guess, remotely. We'll have the camera set up with the projector, excuse me, that has everything that's going on the screen that we're showing. And then we'll have also our mentors and our volunteers will be walking around the room with their phones on Google Hangouts. And they'll be actually like looking at what the kids are doing so that everybody can kind of see what's going on. So if you want to set up like a classroom that everybody's just going to attend remotely and have the Hangout up on a projector screen or something, you can have students attend that aren't actually at the event.
Cool. Cool. Okay.
Thanks. Cool. Any other questions?
Do you have any other questions?
I don't right now. Thank you.
I think we're good.
Okay, like I said before, I'm still going to be in the Slack room. So if you guys have any questions after this, Nicole, she's been posting her project a couple times in there. And I had somebody Donna sent me a private message with her project. If you want me to look at the project, or if you want any of the other teachers to look at your projects and kind of see what you're doing, if you want to create your own, feel free to post it in the Slack room. And
Okay.
Yeah, that's why we were laughing at the beginning. All of a sudden we had Donna on a computer over here. We had Robbie LaPlante on another computer, and they're like, what's going on, you guys? And we're like, listen, we can't get the people we want, but we keep getting these random people.
yeah, they probably, I'm guessing you guys probably either were calling the previous
I
training
think that's
sessions,
what we were doing.
and so they were getting notifications that somebody was back in the room or something. I'm
Yeah,
not 100%
so yeah, well,
sure.
Donna called me and she's like, are you trying to get a hold of me? And I'm like, no. And then I went, oh, wait, it's the...
Nice.
And then all these people just started popping up from all over the district on our computers. So
Awesome.
we don't
Well,
know.
yeah,
what
if you guys have any questions, just let me know and I'll try to answer them ASAP.
Okay, thanks,
Thank
Derek.
you.
Appreciate it.
No problem, guys. Have a great day.
Bye-bye.
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 All right, I gotta get in that Slack room.
Here, I'll help you.